So basically, we have define. We define FOOF to be FOOF.
Hello everyone, welcome to this video in which I'm going to show to you something very interesting, or at least interesting to me, I suppose. It's a Q compiler. Q stands for quantum, and as you can guess, it's a quantum compiler. It's a compiler for the quantum architecture, quantum being architecture for my scrap mechanics CPUs that I'm using. So what we have here is we have a funny little code sample called example.ql. QL stands for Q language, or QLang, or quantum language, or Quantum L. Either way, whatever you want to call it, it's the simple txt file with code in it. So I'm not gonna go into high detail of this entire file because it is kind of long and there's a lot of stuff to explain. But you could read through it. The link will be in the description for the GitHub repository that contains all of these things. I will explain some of probably a little bit more confusing parts. Well, attempt to explain, I suppose. So here, as you can see, you have load some number and store into some variable. Then we have the same thing again. We'll load some value, store it into some variable, load some value, store it into some variable. A lot of repetition. I'd say this is very inefficient. So what we could do is define a macro. We call it macro underscore store, and it will use a few things. It will use value, that's this part that we're gonna use, and we have a pointer. And in that macro, we always load some value. So we do exactly that. And then we store into some pointer. So we do it exactly that, store pointer. And there we go, that's our macro. Now, if we want, we can go ahead and replace this portion of the code with simply this. We underscore store. This is a macro that will use 128 and store it into array ptr. And same for the another one. Store uses 32, and we store into array size. Look at that. So we can replace our this portion of the code with this. Very efficient, very nice, and you could definitely use that. It's a simple macro that you could use everywhere. And when I'll finally implement the bloody include, then I'll add a simple library that will have these kinds of macros predefined, so you could just use them as you want. Right, let's, can I roll back, please? The rest of the code, I guess this is somewhat confusing, but you'll be able to read. I think I've tried to make my programming language, because this is basically a programming language, assembly-like. So, because this is basically like a more user-friendly version of assembly-like language. I don't know how to describe this, but I want for people to kind of try to even use this. That's the whole purpose, right? I want for people to be able to use this thing and enjoy using it rather than suffer in horrible pain like they were before. Because this is quantum language. This uses the Qt specifically, right? It uses the language for my newest CPU lineage called Quantum Tera. So if you remember, before I had Quantum Mini, QM, well, it was called MQ, but I renamed it again to be QM because it's nicer to read. And QM lineage is Quantum Mini lineage. It's a lineage of CPUs under quantum architecture that have that work on 8-bit. So QM is 8-bit CPU lineage. How the fuck do you write this word? I think that's how. And Qt is 16-bit CPU lineage. That's not how you write this word, but I don't care. So Qt stands for Quantum Mini QM, and Quantum Tera is Qt, or Qt, because it's very cute architecture, I suppose. At least I try to make it as user-friendly as possible, so maybe that's the cuteness of it. I don't know. But what we have here is, I think, fairly readable. I mean, this is slightly strange, and what is this computer? Obviously, it's comments. But yeah, there are some quirkiness, as pointers are still a bit annoying, and you just have to write a bunch of code to understand how the fuck do you even work with them, especially in this architecture. But if you want, you can definitely understand this language, I think. So I'll leave the link in the description on to this GitHub repository with the entire compiler, because this language is compiled, and to the emulator, which, because I don't have a CPU yet, Qt CPU, I still have to implement it. It will be called QTR1. But yeah, that's going to be it. Again, all the links to both of the GitHub repositories will be in the description. And for now, I'll show you something that I've done before. So we're gonna open this thing, the most pointer angry piece of example. We're gonna compile that. That's gonna be 267 bytes that will be written to this very funny path. And I'm gonna show you. Let's try to execute it. Wow, yeah, there we go. It took too long because I'm using a hard drive, but there you go. We're done after 19,000 instructions. And let's check our cache dump that I thankfully did. And let's see. What do we have here? 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. Those are prime numbers. So what I've done was I've implemented prime number sieve using this language. So let's go back to compiler. As you can see, this is a sieve of Eratosthenes. I think that's correct. So this is the sieve of Eratosthenes, and here I have the sieve size. I should rewrite this to more modern way, by the way, because like an example, I have defines. Here I also should do sieve size through define, but oh well. Basically, we can change the sieve size to be, oh, I don't know, 1024. Why not? And array start to be at 64. Let's make it closer to like beginning. It's fine, or even 16. So this is basically where our array will start, and this is how big the sieve will be. And for those who don't know, sieve of Eratosthenes is a very nice and very fast way of computing primes. Well, it's not very memory efficient, I think, but it is very fast a way of computing primes. And yeah, so let's try to compile this. We're going to be looking at 1024 numbers, and we're going to start at 16. So it's not going to generate 1024 primes, just to be clear. That's just how the algorithm works. You can check it. So compile that. It goes to emulator again. And we execute it. As you can see, it executed much faster, even though it executed almost 100,000. Again, disk caching is very nice. You shouldn't disable it. But what we have here is 2, 3, 5, 7, blah, 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 blah. And that all the way up to 1021. So this is how many primes we have. There we go. All of these things are primes right here, which is very nice. I'm very happy that this thing fucking works. I'm pretty sure all of these primes, I haven't checked all of them, obviously, but they seem primey, you know? 37, 39, 49, 51, you know? It seems very prime number. I don't have a favorite prime number, I think. Oh, 443. That's the, 443 is a port for an HTTPS protocol. How nice. I don't see 445 for SMB friend, but oh well. As you can see, this thing works. It's very cool. And also you can notice that there is Pygame involved, so that means we may draw something on the screen. So this is basically just a thing that emulates the screen that might be installed, and it also shows like interrupts and shit. So it's mostly for demonstration of Quantum Emulator that will be used in conjunction with Quantum Compiler. Let me compile this. I'm going to compile that. As you can see, it compiled nicely. And let's switch to Q-Emulator. And let's close that. Oh, you're not gonna see it. Ooh, shoot. So, let me show you. Ba-ba! Beautiful. So this is what we... Oh, yeah. Yeah, it works. So yeah, I forgot to disable resizing. That's why we can do this, but... So it doesn't preserve the aspect ratio, but you know, it's fine, it's fine, it's fine, it's fine. And the close doesn't work because it's not supposed to. But basically what you can see, this is a simple graphics that I've implemented for this Q-Emulator. And again, the close doesn't work. Kind of on purpose, kind of out of laziness, but we can keyboard interrupt, it still works. But yeah, although it does exit with an exception, which is not nice. Anyway, that definitely will be it for this emulator and compiler demonstration, and I see you next time. Goodbye.